Hello everyone. In this video, we are going to determine the inverse function given the restriction, and this is the fourth part. Now let's take this example that we have right here. We're supposed to determine the inverse of the function of this function that we have right here, and this is the restriction. F of x is equal to 1/2 quantity x minus 4 squared minus 3. The restriction is x is less than or equal to 4. We are going to first sketch the graph of this function that we have right here. I'm going to show that on this piece of paper right here. Okay, just by looking at this equation that we have right here, we can tell that the vertex for this graph is actually on +4 and -3. Because remember, we're supposed to switch the h and keep the k. So since this is a -4, it's going to come out a +4. So I'm going to write the vertex down here. Okay, now we are ready to determine the equation to use to complete the tables. I'm just going to write that down here. So in order that we can determine the equation to use to complete the table, we're supposed to cover the h and the k. So we're just going to cover the h right here, and we are going to cover the k as well. And whatever is the leftover, that would be the equation that we're going to use to complete the table. So the leftover here is actually equal to y equals 1/2 of just x squared, because again, the h and k was covered. So this is the equation that we're going to use to complete the table. So then from the vertex, okay, so we are going to plug this value into the x right here, and I'm going to show the work on the side right here to solve for the other value that we put into the blank right here. So we go ahead and write that would be 1/2 of our x again was 1 squared. So that's 1/2 of 1 is actually 0.5. So we can go ahead and write 0.5 right here. And then for the other one, we do the same thing, but this time around, we put in the 2. So that's 1/2 of 2 squared. So 2 squared is 4. 1/2 of 4 is 2. This means that from the vertex, so we're going to plot the vertex first. So the vertex, again, is located on 4, -3. So that the x is 4 and then down to -3. So it's going to be down here. So that's the vertex. From there, we are supposed to go 1 right and 0.5. Again, since this is positive, this is actually going up, and this is going up as well. So we go 1 right and 1/2 up. So this is where we're gonna have the next dot. And then to get to the other dot, we go 2 to the right and 2 up. So 1, 2, 1, 2 up. So this is where the other dot is gonna sit. So we're gonna reflect it across, since this is a quadratic equation. So we're gonna reflect that across, and we are going to sketch the graph. So I'm just gonna go ahead and sketch the graph right here. Okay, looking at this graph, this is not a one-to-one function. What does it tell us? This tells us that the inverse of this graph that we have right here is not a function. Because again, if we pass this horizontal line, we use the horizontal line test, we pass this horizontal line, the pencil, this graph is touching the pencil at 2 points as we go up on the graph. This means that, again, the inverse of this graph is not a function. And so that is why in this equation that we have right here, we are restricting this graph. We only consider x is less than or equal to 4. So if this is 4, we only consider the left side of the graph and not the right side. That is what this restriction is telling us. So I'm just gonna go ahead and erase the right side of this graph. So this is the graph that we consider. This is actually our given function, f of x. So I'm just going to label this as f of x right there. Now, looking at this graph right here, we can say that the domain for this function that we have is actually x is less than or equal to 4. So anything to the left of 4, that's the domain. Well, the range is y is greater than or equal to anything that is greater than -3. So that's the domain and range for this graph. Now, we are ready to determine the inverse for this graph. So I'm just going to go ahead and write this equation up here. There are steps that we need to follow in order that we can determine the inverse of any function. The first step is to replace f of x with y. So this f of x will become a y. So I'm just going to go ahead and rewrite this. The second step is to replace every x with y and replace every y with x and solve for y. So pretty much this y that we have right here will become an x and this x will become a y. So this equation would come out. Part of this step is to solve for y. So we're going to isolate y by itself. So that's our target. So then we can go ahead and add 3 to both sides and then plus 3 here. So then our equation would come out. That would be, we can cross this out. So that is x plus 3 equals 1/2 of y minus 4 squared. Now, we still have the 1/2 here. Again, we want the y by itself, and we still have the 4. The trick, in order that we can get rid of this fraction right here, is to multiply both sides by its reciprocal. So then we are going to multiply this by the reciprocal, means we flip it. So that would be 2 over 1, but we don't need to write the 1 underneath the 2. So we can just go ahead and write 2 right here. And we multiply the same thing on the other side. We multiply by 2. So that if we do that, we can cross out the 2 and the 2 here. So we are left with... Now, we are going to solve y by itself so that we can go ahead and get rid of the squared here by putting a square root to both sides. So once we square root both sides, we remember that there are 2 values that we're going to get. It's going to be the positive and the negative. So that we can go ahead and rewrite this as... Okay, since we want y by itself, we can go ahead and add 4 to both sides plus 4. So then our equation would come out. So we already have solved for y by itself. Now remember that this 4 is outside this square root symbol. Now our question here is that which one do we pick, the positive or the negative? We are going to look at the restriction. The restriction tells us that we are supposed to only consider x is less than or equal to -4. So if we say less than, we take the negative value of these two. So we are taking this negative. So that would be the sign that we're going to take. So we can go ahead and move on to the third step. The third step is to replace y in the equation solved in the second step with f -1 of x. So that we can go ahead and write the notation for inverse. That's f -1 of x is actually equal to negative square root of 2 quantity x plus 3. And then again, the 4 is outside the radical symbol. So this is the inverse of this given function that we have right here. So this restriction less than is represented in the inverse as negative. So then we are now going to graph this inverse function. So I'm going to use this paper right here. Okay, now looking at this equation that we have here for the inverse, our vertex is, again, we switch and keep. So that means our vertex is located on negative 3, 4. So then we can go ahead and determine the equation to use to complete the table. So in order that we can determine the equation to use to complete the table, we are supposed to cover the value of the h and k. So the equation that we're going to use then are the leftovers. So that would be y is equal to negative square root of 2x. So this is the equation that we are going to use because, again, we covered the h and the k. So that from the vertex, okay, so we're going to use this equation. Again, the equation is y equals negative square root of 2 parentheses x. So we are going to plug this 1 and 2 into the x and we solve for y, and that's the one that we put in here. So that we can go ahead and say that we plug this in. Okay, since the value that we got is negative, this means that we are going down from the vertex. So we can go ahead and sketch the graph here. So from the vertex, our vertex is on negative 3, 4. So that would be on negative 3 and up for 1, 2, 3, 4. So this is where the vertex is going to sit. And then from the vertex, we go 1 right and then 1.4 down. So 1.4 could be somewhere around here. And then we go from the vertex 2 right, 1, 2, and then we go 2 down, 1, 2. So it's going to sit here so that we can go ahead and connect these dots together to create the inverse graph. So this is how it's going to look like. Okay, so from here, we can already determine the domain for our inverse graph. So the domain would be anything that the value for x is anything greater than negative 3. So x is greater than or equal to negative 3. And the range for this would be y would be anything less than or equal to positive 4. So that's the domain and range. Now, looking at this graph that we have right here, we can say that this two are inverse of each other, because if we are going to sketch the line of symmetry for inverse, which is at y is equal to x, this graph right here, you can see that these two graphs are actually symmetric with respect to each other, which means that if we fold this graph into half, passing through the line of symmetry y is equals to x, they're gonna match up. We can go ahead and label this as our f negative 1 of x. On the side, you will see the graph of the function and its inverse. You can see that this graph that we have created is actually the same as that of Desmos. And then again, these two graphs are symmetric with respect to the line of symmetry y is equal to x. That's it. If you find this video helpful, hit like and subscribe for more math videos. See ya!